Taylor.
Hello.
Good. Okay, do we want to pick up on this document,
Sure.
or do you have a new one?
That works.
Okay. Do you remember
Wait,
what?
hold on. I think. Hold on, I'm gonna check real quick.
All right.
Actually, it's just what we've been doing. That works.
Okay. I remember talking about 8 and also 9, but maybe just generally.
Okay.
Remember 8, the reason I remember it is because we talked about what it was, which was a transformation of this function. In other words, put it back on red. That's y equal x cubed. And on 8, it's y equal minus 2x cubed plus 1. So we have a vertical shift of plus 1. We have a reflection over the x-axis because of the negative sign. And we have a vertical stretch factor of 2. So it would take that, move everything up. Always do your reflections first. So let's see. I would draw it like that. And I then move it up 1 and stretch it by a factor of 2. So it looks like this. And that's going to be y equal minus 2x cubed plus 1. And then determining the inverse is pretty straightforward. You got that down, you think?
Yes.
Switch the variables, solve for y. And that's going to work on all of these problems I'm looking at here. There are some that it wouldn't be that easy. If they had a quadratic anywhere here, then it's much tougher to solve for the inverse. But let's only work on what we're looking at. And I think that's the directions for 8 and 9. Graph the function and its inverse. Well, over here, what I have graphed is the blue, that's the function. And if I wanted to graph the inverse, what do I do?
You would have to
Graphically, what does an inverse represent?
a reflection.
Over what?
The x-axis or y-axis.
It's over the line y equal x. The line y equal x is this line right here that I'm drawing in dotted.
Okay.
Okay, that's a slope of 1, x-intercept or y-intercept of 0, so it's y equal x. And what we would want to do is take our blue graph and reflect it over that line. And that's what the inverse is going to look like. And then, of course, you know how to algebraically solve it, so we don't need to spend time on that. But in terms of graphing it, that's probably the best way to think about it. And do you have any problems knowing how to reflect that graph over that line?
No. I just put in the calculator and it's perfect.
Okay. And also, you can just think of whatever point is on that line, put it on equal and opposite distant on the other side of that line, perpendicular to it.
Okay.
Connect the dots and you end up with the inverse function.
Okay.
All right. Number 9 is actually easier. That's also linear. In other words, that's the same as minus 1/3 x minus 5/3, just a straight line. So finding its inverse is going to be easy, and graphing it's going to be even easier.
Okay.
Let's go to 10, because now we're asked to prove that one is a inverse of the other. Show are the following inverses of each other, and show algebraically and write yes or no. Let me blow this up a little bit. Look that readable. Now it is. How am I going to algebraic? Well, first of all, how do I know if they're inverses of one another? I guess I can go through each one and solve it, huh?
Yes.
That's one way I could do it, is I could switch the variables, solve for y, and see if I get this over here.
But my teacher said that all I have to do is find one, and if it seems like it would not be the inverse, then I can just put yes or no.
Well, there is a exact definition of what constitutes an inverse. And in this case, what it would be, and tell me if your teacher has told you this or not, I would think that you have to have had this. If f of g of x is equal to x, then g of x is the inverse to f. Okay?
Okay.
So, let's figure out what f of g of x is. First of all, let's talk about notation. If I have the following function, completely different. What is f of 2?
I would plug it into the x.
Don't use your calculator. I'm trying to point out a concept here. Oh, right. We'd plug 2 into x, and so 2 cubed is 8, right?
Yeah.
All right. The concept being is that whatever's in the parentheses, what if I said, what is f of x plus 1? What would that be?
That would be x plus 1 cubed.
Correct. So the concept being whatever's in the parentheses, we're going to plug in for x whenever we see it. Okay. So here, when we see f of g of x, that's the same as, well, what is g of x? G of x is minus 2 over x plus 1. And what is f of x? F of x was defined to be minus 2 over x minus 1. So, what's our f of g of x going to come out to be? In other words, what is f of minus 2 over x plus 1 equal in this case?
That would equal.
Go into that function, wherever you see x, plug in what's in the parentheses.
Okay. So then it would be negative 2 over negative 2 over x plus 1 minus 1.
Yeah, you got to be a little careful here with your notation. Make sure you're writing it correct. Okay. And I still have this minus 1 out here, right?
Okay.
Okay. Now, how do we simplify that?
Could I multiply the bottom by...
How do you divide by a fraction? That's what we're doing here, is we're dividing minus 2 by this fraction.
You flip and multiply?
Yes. So when I flip and multiply this, the 2's and the minuses are going to cancel, and I'm going to end up with x plus 1. Minus.
Okay.
Or x. In other words, that proves that g of x is the inverse function of f of x. Now, usually the proof will require two things. One is this has to be true, but also the reverse has to be true. In other words, g of f of x has to also equal x. Now, I've never come across a function where one was true and the other was not. So I've always been relatively satisfied with just proving one of them. In other words, once that comes out to be x, then it's okay for me to say yes, one is the inverse of the other. Possible, I don't know your teacher, but it's possible your teacher may want you to do both. In other words, you'd have to show that g of f of x is also equal to x.
Okay.
Okay? But as long as you can do it, and if you can do one, you can pretty much do all of them. Let's test number 11. Let's have you tell me whether that's the inverse of it or not. So my test has to be f of g of x has to be equal to x for me to say yes. Okay, what are the steps? What's the first thing I really should write? Don't leave any steps out either. I think it's important to write that middle step in there.
-1 over x plus 3.
Well, f of -1 over x plus 3. See why you have to have the f of?
Yes.
Okay. And what's that equal when I plug it in? In other words, that's g of x. So f of x was, let me write that here.
-x minus 2.
X equals 4 over minus x minus 2 plus 2. So when we write that, what are we writing?
We would have to do 4 or -1 over 4 over -x minus 2 plus 2 plus 3.
Okay, I'm not quite sure I heard you correct, but correct me if I write it wrong. We're writing 4 over, and wherever we find x, we're substituting what's in the parentheses. Correct?
Yes.
Okay. And now, this is a little tougher to simplify. How do we solve this?
Flip and multiply.
You can't do that when there are two terms in the denominator. In other words, the only way flipping and multiplying works is if you have turned the denominator into a single rational quotient. Okay? So let's go up here. Let me write it. In other words, we have to solve this problem. That's our first step. We have to turn this into a single numerator and a single denominator. How do I do that? Before I can flip and multiply up here, I've got to do that.
Could I multiply the bottom, or both sides by the bottom, or the denominator?
Find a least common denominator. Whenever you're subtracting or adding two things, you always have to have a common denominator. Let's simplify things a little bit here and take these two negative signs and get rid of them. Now it's a little easier. What's our common denominator need to be?
-1 over x plus 3 minus 2.
For right there. If I'm taking 1 over x plus 3, I got rid of the minus signs.
Okay, then it would be x plus 3.
Okay, so it's x plus 3 minus, that's my denominator, minus, and x plus 3 here. We have a 1 here. What goes right there?
2x minus 6.
Actually, it's got to be 2x plus 3, right, for starters.
Yes.
And now when I multiply that together, it's 2x plus 6, but it's still in parentheses.
Yes.
I mean, I need to put it in parentheses. This is actually an excellent problem and a very difficult problem because there's all these little traps that it's really easy to make arithmetic mistakes. But now I have a common denominator, so I can just combine the numerator. So the numerator becomes 1 minus 2x minus 6, or minus 2x minus 5, all over x plus 3. So that's what this is. Okay? Notice that it's a single rational quotient now. In other words, now I'm in a position where I can flip and multiply.
Okay.
Okay? So let's do that. Flipping and multiplying means I'm going to have x plus 3 over minus 2x minus 5. I'm going to multiply the whole thing by 4. Then I got this plus 2 over here. Is this thing going to equal x? Is this quantity going to equal x? Take a quick look at it.
It'll be 2x 3.
It's virtually impossible for it to equal x because you're going to have a 4x there and a minus 2x there. So there's no way it's going to equal x. I would need an x squared in the numerator somewhere.
So I could cross out the x's.
Well, you can't really cross out the x's. That's not algebraically permissible.
So if I had the x squared, I was saying I could.
Oh, right. At least you would have a hope of narrowing it down to an x. But this is not going to come down to x. In order to do this arithmetic or algebra, I have to do the same thing. I have to find a common denominator, which is this, apply it, reduce my numerator, but then I'm going to have some number of x over some number of x. And either the x's cancel, leaving me with a number, or I've got some x over some more x, but there's no way I'm ending up with x as the answer. I cannot get that right there from this. So these two functions are not inverses of one another. Now, tell me again what your teacher told you as to how to answer these questions. She said find one, what'd she say?
She said that if I found one and it didn't look like it'd be the inverse of the other, I could just put yes or no. I wouldn't have to do them both, she said.
So she's saying do the f of g of x, but you don't have to do the g of f of x.
Yes.
That's what she's saying. Okay. But there's no way to avoid doing this composite function. That's kind of the essence of inverse functions, and the toughest part for most everybody is doing that. You can see why. The algebra is a nightmare almost. By that, I mean, it's not so tough. It's just really easy to make a mistake, and if you make one mistake, you're screwed. You're going to end up not having x, and you're going to have the wrong answer. So the only thing I can say on trying to prove two functions are inverses of one another is be very, very deliberate on your algebra and do it step by step, kind of like I've done it here, just so you don't make mistakes. But even this is pretty hard to do.
Mm-hmm.
I mean,
Yeah, it is.
as you can see, it was not easy to do any of these. The algebra. Okay. We got about 10 minutes. Do you have another one you want to verbalize maybe?
1 second. I'm gonna pull it up on my iPad.
Okay.
I have actually I think it'd be better if I email this to you.
Okay.
Okay. Since
Seems to go pretty fast when you do it that way. Boy, really fast. I don't ever get it. I never get it that quick. And I'm getting it normally from students here in Colorado. You're in Florida. I would think it would be slower. All right. What do we want to do here? You want to talk about domain and range?
Yes.
Okay. What's the domain on 1?
It'll be
Did you draw these yellow lines in there, or did the teacher?
teacher.
Okay.
So 1, 2, 3.
Yeah. Nice of them to grid this thing. Okay.
So it'll be -4 to infinity.
Well, that's why I asked the question. Notice there's no arrow on the end of this thing.
True.
So does it, and yet there's an arrow over here. So I'm presuming the absence of an arrow means that the function ends right there.
Yes. So then it'll be -4 to 5.
I think that's 6. Oh no, you're right. That is 5. Are you familiar with interval notation?
Yes, with the brackets.
So what's the interval notation for this domain?
Bracket -4.
Actually, it's open paren on the negative side because that's an open circle.
Okay.
And it's a bracket on the positive side because that is not an open circle. It's a closed dot. Typically, they would make that a bigger dot. That's why I was a little confused. But we will assume that that's a big closed dot. But it's not always a dot, I guess. I mean, if you're plotting the square root function, you plot it like that. You don't always put a big old dot right there. So I think the absence of the arrow means it does end there. Okay, and what's the domain? Or what's the range? That's the domain. Range is what?
Then the range is 1, 2, 3. So it'll be 3 to
Now remember, the range is the y values.
yes.
Possible y values. So where are you getting 3?
I'm looking at where the little circle begins.
Actually, though, is all we care about is where the top is and where the bottom is. Anything in between we're not going to talk about. Remember, we're only talking about vertical now. Up and down is range.
So 5.
Well, what's the bottom end of the range?
The bottom end is -1.
What's the top end?
Oh, okay, never mind. You go from bottom to top. So -1 to 5.
Okay. Now, gosh, for some reason in my head, do you use interval notation on range? I guess you do. Yeah, okay.
Yeah.
So this is the domain, this is the range for number 1. How about number 2? What's the domain?
Then number 2, the domain is -infinity to 1, 2, 3, 4, 5, 6 to 6.
Bracket or parentheses?
Bracket.
Infinities always have parentheses next to them.
Because it's not on the graph, right?
No, it's not really a number. In other
Okay.
words, infinity is growth without bound. So it's not really proper to even think of it as a number. So there's no way it could have a bracket. That would indicate that there's a number and it can be that. But and what about the range?
In the range, would that be negative infinity to 1, 2, 3 to 3?
Correct. With a bracket.
Yes.
Okay. Let's see, what else do we have on here? Which one do you want to do? We got time for one.
We can do 3.
Three's pretty straightforward.
I'd say let's do 5, man. Let's do 5.
Okay. If I'm graphing 5, using your calculator, I know it's this parent function shifted down by 2. So it's that kind of parabola.
Yeah.
Okay. And find the y-intercept. Where's the y-intercept there?
Negative 2.
Correct. And the y-intercept is always found by just substituting 0 for x. Because when you're on the y-intercept, that's what x is 0. So the y-intercept's 4 minus 25 minus 2, square root of 3. So always remember that y-intercepts are when x is 0 and x-intercepts are when
Where
y.
did you get to 25?
What's that?
Okay, never mind. That makes sense. Okay.
Yeah, x-intercepts are where y equals 0. So if it wants the y-intercept, but it also wants the zeros, so finding the zeros for this function would be letting f of x equal 0 and solving that. Well, when I solve that, I get x equals plus or minus the square root of 2, which tells me that this value right there is plus square root of 2, comma 0. This value right here is minus square root of 2, comma 0.
Okay.
Okay? It's always harder to find the x-intercepts than it is the y-intercepts, as you can see. You can pull the y-intercepts almost directly off of the function without doing any math, whereas finding the x-intercepts requires you to set y equal to 0 and then solve the equation for x. So it's a little harder, but not that hard.
Okay, thank you.
Okay, Taylor, talk to you next time.
It sounds good. Bye.